Welcome back to Hidden in the Stars. While going through our topics, I noticed we've missed some big ones: redshifts and blueshifts. How do we measure relative motion of celestial objects? What about the expansion of the universe? Well, we measure its redshift or blueshift. The difference between the two is that redshift indicates an object is moving away, whereas blueshift indicates that an object is moving closer towards the observer. The greater the redshift is, the faster and further the object is receding. Blueshift and redshift are opposites, sort of how you think of blue and red being temperatures, like cold and hot, except in space, blue indicates hotter and red indicates cooler. Notice how I said, how do we measure relative motion of celestial objects? Relative motion has a specific definition. It is the concept of an object's motion in comparison to another object or observer. We could be talking about things like the Doppler effect, which is sound changing as it moves towards or away from you. Think of a siren that spins. It gets louder as it faces you. This is the Doppler effect. Redshift for sound moving away and blueshift for sound moving towards you. Cosmological redshift has more to do with light instead of sound waves. If you figured it out, it all has to do with wavelengths. Expansion of space causes light waves to stretch. As we saw in the video on the electromagnetic spectrum, longer wavelengths correspond to redder light and shorter wavelengths correspond to bluer light. Hopefully that makes sense. So as things are moving away from the observer or object in space, creating longer wavelengths, the color becomes redder, and the opposite. This helps us measure distances of galaxies using Hubble's law. Briefly, Hubble's law says the recessional velocity of galaxies is directly, not inversely, proportional to its distance. These redshift measurements not only support Hubble's law, but the idea that the universe is expanding. A good example of a blueshift is that of the Andromeda galaxy, which we know is moving towards us. As mentioned in the Fate of the Milky Way video, the Andromeda galaxy will eventually collide with the Milky Way. By measuring the blueshift, we've been able to not only figure this out, but make calculations and predictions about when this will happen and what might occur when it does. Perhaps the best example of blueshift is a binary star system. Redshifts and blueshifts help astronomers to look at expansion rates of galaxy formations, and therefore formation of the early universe. Without the notion of these shifts, we may not know about the universe's past or be able to predict its future. Something important to note is that these shifts can occur due to gravitational effects, even though they mostly occur because of universal expansion. Redshifts and blueshifts occur all throughout the universe and are an absolutely crucial astronomical and cosmological concept. To remember these terms, just break down the words. They're quite literal. The relative motion, remember, it's relative motion, caused the object to shift to either the red or the blue end of the spectrum. Red is further away, blue is closer. It might seem silly, but I think about it in alphabetical order. B for blue comes before R for red, therefore blueshift is closer than redshift. Come up with a little jingle or something to help yourself remember. We're so used to red and blue indicating hot and cold here on Earth that we forget that they have other meanings, and even us astronomers can get confused sometimes. What do you think? Are most things in the universe being red-shifted or blue-shifted relative to us? Do we really want things to be blue-shifted? Think about what that would mean for a minute. Thanks for tuning in to this moving episode. Join us on our journey through the cosmos. Catch you next time on Hidden in the Stars.